Okay guys, so I got your messages, and let's go ahead and do another problem where we are asked to graph a piecewise defined function. So in this case, today we are going to graph a piecewise defined function that is defined not by two pieces, but as you can see, by three pieces. And once we do that, let's not forget to evaluate the function at those given values, namely -4, 1, 3, -2, and -5. So let's get this show up and running. So the first piece 1, that is defined by f of x equals this for this domain. But again, we're going to take a small pause on function notation. We'll just replace it with y. So piece 1 is defined by y equals -x plus 1, and we have to pay attention to the domain. Sorry for the stuttering. So this piece equals -x plus 1 if x is less than -4. So for all values under -4, we're going to go ahead and use this piece. Now the degree in this case is 1, or the biggest exponent on any of the variable terms. The degree is 1, so the graph is going to be a line. Okay, the nice thing about graphing lines is that we just need 2 points to do the line. So we're not supposed to pick -4, but with your permission, we'll knock out -5 followed by -6. Okay, my mental math game is a little bit off, so we're going to see how this goes. So if x is -5, -5, or opposite of -5 is 5, 5 plus 1 is 6. Let's go ahead and lock it in. So we have -5, 6. Hopefully I do this right, because these numbers are too small for me. Okay, cool. So again, to do the graph of a line, we need 2 points, 3 if we're overachievers, but we have no time for that. -5 integers, we'll pick -6. When x is -6, opposite of -6 is 6, and 6 plus 1 is 7. So that's good enough for me. So we go 6 to the left, and then 7 units up. So that's 6. Oh, my hand is in the way. I think I did it right. Let me know if I didn't. Cool. So then we're going to take our straight edge and connect those 2 points. But the question is, up to where are we going to stop? So we're going to stop once we reach -4, but I don't want to graph it. I want to highlight that -4 is not in this domain. So we're going to evaluate at -4, and then we'll put an open circle. So let's go ahead, put -4, and then a love note, open circle. If I don't speak to myself, if I don't write this, I know that I'm gonna graph it like we did our earlier 2 points. So we have to fake graph it with the fake pointer, open circle. If x were to be -4 and it was possible, opposite of -4 is 4, and 4 plus 1 is 5. So remember, open circle at -4, 5. So 4 left and then 5 up. Oh, that's pretty nice. Okay, so we're gonna connect all these 3 points. Let me go ahead and take my straight edge. I'm gonna rotate this. That's the only way I'm gonna have a fighting chance of making it neat. So we're gonna connect these 2 points, trying to make sure we don't extend trying to make sure we don't go past x equals -4. Okay, so we have a line going down. Fantastic. So 1 piece down, 2 more to go. We got this. Okay, so piece 2 is a little bit more spicier. So we have f of x equals, but again, we're taking a small pause from function notation. So we have f of x equals square of x plus 2 less 5. So you have some options. Option 1, you can take advantage of the fact that we have the green light to use a graphing calculator. Yeah, you read that right. You may use a calculator to support your answer. I meant to write you may use a graphing calculator, but you hear me now. Okay, so you have some options. Okay, you can punch it in. Yeah, that's not where I was trying to go. Okay, so that's not where I'm trying to go. Sorry. Okay, so you can punch it in. Y equals square of x plus 2 minus 5, and then we hit graph. Or you can apply your skills from earlier sections and apply transformations of the graph. I don't really care. No one's gonna know. But I'm gonna pretend that I forgot my calculator for the day. Okay, so let's do this. If the domain, sorry. If -4 is less than or equal to x, and that is less than 1. So in short, for values between -4 and 1, where -4 is included and 1 is excluded. Okay, so this comes from the graph of y equals x squared. And this is written in remember, horizontal shifts are given of the form f of x minus c. So we need to write this as a subtraction problem. So we'll write this as x minus negative 2. Okay, subtracting negative 2 is the same as adding 2, so we're good. So from the graph of this, from the graph of y equals x squared, we're gonna shift 2 left, then 5 down. Okay, why? Because we're subtracting 5. So let's go ahead. We are at the origin, because this one starts at 0, 0. When x is 0, y is 0. So from this graph, we're going to shift 2 left and 5 down. So 2 left and then 5 down. That will bring us at negative 2, negative 5. I am so confident with our transformation of the graph that I'm going to go ahead and lock it in. But like sometimes, as humans, we tend to doubt ourselves. So we'll do the arithmetic, okay? So if x is negative 2, negative 2 plus 2 is 0, square of 0 is 0, and 0 less 5 is negative 5. So we're on it. Now, what other value should we pick? We have a sense of what it should look like. We go 2 left, 5 down. Pretend I went 5 down, and it looks something like this, okay? This piece is not a straight line, so I'm pretty sure the greater, who are we kidding me? I'm pretty sure we're going to have more flexibility, okay? So you have some options. You can start picking values to the left of negative 2, because that's what we had, values to the right of 2. But with your permission, I'm going to go straight to the endpoints, and if I feel like I need to, I'll pick points in between. So I'm going to pick negative 4, and then fake point or open circle at 1, okay? So if x is negative 4, punch it in, or if you freehand it, negative 4 plus 2 is negative 2. Square of negative 2 is 4, I believe, and 4 minus 5 is negative 1. Okay, pretend I wrote all of that, but just punch it into your calculator. So let's go ahead, locate that. Negative 4, negative 1. So 4 left, 1 down. Okay, so these are the endpoints. Okay, and then 1 is not in this domain, but I want to know where do I stop, because I need to do my graph. I'm sorry for the stuttering. I need to do my graph, but I need to know up to where do I stop, because it doesn't go indefinitely in each direction. So let's go ahead, pick 1, and then put a love note, open circle. Okay, pretend you can read that. So if x were to be 1, and if n were to be in this piece, it's not. 1 plus 2 is 3, square of 3 is 9, and 9 less 5, I believe, is 4. So let me go ahead, circle that to remind me that it's out. Okay, so open circle at 1, 4. So 1 right, 4 up. And then you have some options. If I was using a pencil, I would tell you right now. Did I do this right? Negative 2, negative 5. Yeah, negative 4, negative 1. I think so. I don't know why I'm doubting myself. Okay, cool. All right, so we can just do our best to do our figure, or we can find more ordered pair solutions. It's really a personal choice. I will be okay with that, but I'm an overachiever, so I'll pick negative 3, negative 2, negative 1, and 0. Okay, so let's go ahead, extend this. I'm out of space. So we have negative 4, negative 3. If x is negative 3, that will give us negative 3 plus 2 is negative 1. Squared negative 1 is 1. 1 minus 5 is negative 4. So we have negative 3, negative 4. Negative 3, negative 4. Cool. X is negative 2. We already have that. How about negative 1? No, we don't have that. Okay. So again, this is all for fake extra credit. I just want that low point and then the end points, and you're good. Okay. Negative 1 we said, right? Okay, cool. So if x is negative 1, where am I? Negative 1 plus 2, I believe, is 1. The square of 1 is 1, and 1 minus 5 is a negative 4. How about that? Okay, so we'll talk about symmetry in a later section. Okay, so negative 1, negative 4. And again, you're like, Miss Tori, this is a lot of points. I mean, a lot of work. Yeah, we're doing this for fake extra credit. So I just need that bottom one and then the end point. So like the one at -4 and the fake point or open circle at 1. So we have -3, -2, -1. How about 0 for the grand finale? So when x is 0, 0 plus 2 is 2, square root of 2 is 4, and 4 minus 5 is -1. So let's go ahead, lock it in. 0, -1, we stay put, and then go 1 unit down. So the one advantage of putting extra points is that it makes it a little bit easier for you to do your sketch, supposedly in theory. So we'll see how this goes. I'm no good at drawing, so I'm going to try my best. I'm really good at doing the graph of straight lines, but not so much of things that are not straight. I try my best. I think that's pretty good. Yeah, so proud of me. Yay me. Cool. All right, 2 pieces down. One more to go. For the grand finale, we have f of x equals -3.5. But again, we're going to take a pause on function notation and just write y equals -3.5. So piece 3, where am I? Piece 3, we have y equals -3.5, and this too is the graph of a line. It's a horizontal line, but you don't have to memorize that. You can punch it in, or you can let the work speak for itself. And the domain is if x is at least 1. So if x is greater than or equal to 1. So we'll do our table of values. If x equals 1, you guessed it, y equals -3.5. Let's go ahead and graph it. So we have 1, comma 3.5 negative, so we'll say that's about there. Another x value, we need two points to do a line, and if x is 2, as you can see, y is still -3.5, and that's good enough for me. Okay, so we're gonna take our straight edge and connect the points. Please make sure you graph points that are strictly at least 1 because of the domain. We can't go to the other side. Fantastic. I need to stop watching these radio shows. I hear them so much that I keep saying those words. Well, at least they're positive words, so that's good. Okay, cool. All right, so I'm proud of us. Yay us. Okay, cool. So we graphed this pretty intimidating problem, and I feel like if you can do this problem, oh, you can do any problem, trust me. Okay, so I was about to say thank you, but I just realized that we need to evaluate that function. Okay, so f of -4. So let's see what piece this is in, if it's in the first, second, or third piece. -4 is in the domain of the second piece, so I'm gonna put a little love note. I'm gonna say P2. That's my made up abbreviation for piece 2. I'm trying to project everything. Okay, I think this will be good. Okay, so f of -4, oh, we said piece 2, so -4 plus 2, it's okay, is -2, square root of -2 is 4, and 4 minus 5 is -1. So I would have done this so much faster if I showed my work, but I'm trying to impress you guys. Okay, so f of 1. What I tell my students, you not showing work does not impress me. Okay, yeah, you can show all the work. Okay, I'm impressed very easily. Okay, so when f is 1, 1 is in the domain of the third piece. Oh, I love that one. Thank you, third piece. We've earned it. So f of 1 will give us -3.5. F of 1 equals -3.5. Up in the list is f of 3. Let me go ahead, lock it in. 3 is in the domain of also the third piece. I forgot to put piece 3. Piece 3. Okay, so 3 is in the domain of the third piece, so f of 3 also equals -3.5. Up in the list, we are asked to evaluate f at -2, so f of -2. -2 is in the domain of the longer one. -2 is in the domain of the second piece, so let me go ahead put piece 2. No, now on the assessment, do I need to see this? No, that's just for me because I love speaking to myself. So if x is -2, oh, I like that one. -2 plus 2 is 0, square of 0 is 0, and 0 less 5 is -5. Cool, fantastic. Look, it's all about possibility. For the grand finale, oh, how exciting. f of negative 5. So negative 5 is in the domain of, I think, the first one. So if x is negative 5, negative 5, or opposite of negative 5 is 5, and 5 plus 1 is 6. So that gives us f of negative 5 equals 6. So I know we nailed it, because if we didn't, you would have told me. But you know, the overachiever in me says, let's go ahead and confirm it with our graph. F of negative 4. So when the input is negative 4, the output is not my laptop. Okay, so when the input is negative 4, the output is not 5, because that is an open circle. The output is negative 1. Oh, look at that. I'm crying. Tears of happiness. F of 1. When the input is 1, the output is not this fake point. The output is negative 3.5. Fantastic. F of 3. When the input is 3, the output, or the function value, is negative 3.5. Oh, crying. We're almost done. F of negative 2. Where am I? And then we're gonna locate this. That will give us negative 5. Perfect. For the grand finale, I mean, if we got these 4 problems correct, you know we nailed the 5th one. Okay, f of negative 5. When the input is negative 5, the output is, according to our graph, 6. Oh, how exciting. Thank you guys. Until next time.